So another transformation we can do is a horizontal shift. Okay, and we also call this a phase shift. So when we talk about phase shift, we're talking about horizontal shifts. And since it's horizontal, it's going to be embedded inside the sine function. And it works just like we did with all other functions. So if we have sine theta minus p, the p factor is going to shift that graph left and right. So if we have plus p, it's going to shift to the left, minus p will shift to the right. So here I have the original sine function. Okay, it's 0 to 2 pi period. And in red, we're going to sketch what sine of theta minus pi over 2 is going to look like. Well, that minus pi over 2 ends up being a horizontal shift to the right pi over 2, or 1 quadrant. So that point gets shifted here. We get our maximum shifted here. The 0 gets shifted over 90 degrees, and that minimum point gets shifted over 90 degrees. Okay, I'm going to get rid of that dot. The min here gets shifted over 90 degrees, and every coordinate again is shifted 1 quadrant in this case. So as I draw in those points, I can see that sketch in the quadrants. And as I sketch in the quadrants, I can see every point has a phase shift of pi over 2, or quarter period. Okay, so that pi over 2 minus pi over 2 shifts to the right pi over 2. When we look at this phase shift of theta plus pi over 4, that's going to shift it to the left. It's going to shift it this direction, and every point then gets shifted just 45 degrees, or half a quadrant over. So that point gets shifted here, this point gets shifted here, this point gets shifted here, and every point gets shifted over half a quadrant. Okay, so those still represent quadrant boundaries, so I can still draw my 4-part symmetry based on my quadrants. And that green graph then has been shifted to the left 40 pi over 4, or 45 degrees. So I'm just going to finish shifting these points here. Every coordinate gets shifted over pi over 4 radians, or 45 degrees. Okay, so we can see the green graph then is a horizontal shift to the left of pi over 4. So now when we're graphing these, we want to start keeping track of the 4 main parts: the amplitude, the vertical shift, the horizontal shift, and the period, which relates to the horizontal compression value. So in this case here, I'm going to start with my amplitude. The amplitude is based on the coefficient in front. So in this case, there's no vertical expansion or compression, so the amplitude is 1. My vertical shift is based on the outside part. Okay, so this outside part here, plus or minus something, that's going to give us our vertical shift. So in this case, we can write plus 0, so that we have a 0 vertical shift. So when I have that, I know that my middle line is represented by the x-axis. The horizontal shift is going to be based on that term there. And so we know our horizontal shift is going to be, in this case, it's plus pi over 2, so it's going to be to the left pi over 2. The period has not changed, so the period is 2 pi. So when I draw this, I want to start with my horizontal shift. I'm going to shift it pi over 2. It's going to go shift to the left, so that's negative pi over 2. And then we want to use the period to get the endpoint. So it's going to go plus 2 pi. So I'm going to end up at 3 pi over 2. So there it is. There's my start point at negative pi over 2. My end point at 3 pi over 2. I'm going to draw in my quadrants. So midpoint by my midpoints between my end and start, and then between the middle and end. And then I'm going to draw this in. I have my middle line. I have my 4 quadrants. I can use my amplitude now to draw this graph in. So my amplitude is 1. It's a cosine graph, so sine starts in the middle, but cosine starts up 1. So we're going to mark that as positive 1. It's going to go down to 0, and then it's going to go down in the next quadrant to negative 1, back to 0, and then back up to positive 1. So then I have my main reference points for each quadrant. I can just sketch that in. I'll just draw that a little bit nicer than that. Okay, so the curve has 4-part symmetry. It's going to look like that, through that way. And there it is. Doesn't have to be work of art, but we can see that we have the 4-part symmetries. We have the quadrants marked off. We can label the min and max points. So that's going to be negative pi over 2, positive 1. This point here is going to be at positive pi over 2. This will be 3 pi over 2 here. So this is going to be pi over 2 and negative 1. And that represents the minimum point. So we have a little bit more going on here. We have a vertical expansion, vertical shift, and a horizontal shift. So we're going to keep track of these parts. So the amplitude, we want to make note of. It works out to be the vertical expansion factor. Our vertical shift is going to be the outside component. So it's going to be, in this case, plus 2 on the outside. The horizontal is always on the inside. So we have our horizontal shift component on the inside. It's minus 2 pi over 3, so we're going to shift to the right 2 pi over 3. And then our period, there's no horizontal compression, so it's going to be 2 pi. So the b value, there's no b value, so there's no horizontal compression or expansion here. So we want to organize how we're going to graph this. So we want to do our horizontal shift. And we need to make sure that when we do our horizontal shift that we can still fit in our whole period of 2 pi. So when I'm going to mark off my horizontal shift of plus 2 pi over 3, I'm going to mark it off here. That means that each one of these lines is 1/3 pi, so I'm going to need 6 of these to fit in my full period. Okay, so I'll have 1, 2, 3, 4, 5, 6. And so the end position here, that represents the end point of my graph. Now we need to start identifying the coordinates. So I have to add from 2 pi over 3, I'm going to add 2 pi. So I'm going to need to add fractions here. So I'm going to use a common denominator of 3. So it's going to be 6 pi over 3 plus 2 pi over 3. That gives me 8 pi over 3 as my end point. I'm going to divide this into quadrants. So I know it's going to be halfway here, and then half of half. So it's going to draw it in here. And I want to find out the location of these points. Okay, now the location, it's easy to calculate if we use that average formula. So halfway between 2 pi over 3 and 8 pi over 3, I'm going to add 2 pi plus 8 pi is 10 pi over 3 divided by 2 is going to give me 5 pi over 3. That's my middle point. I could do the same between 5 pi over 3 and 8 pi over 3. 5 pi plus 8 pi is 13 pi over 3 divided by 2 gives me 13 pi over 6. Okay, so I put that divide in the denominator, so my denominator goes from 3 to 6. So I'm going to do the same for the first quadrant. 2 pi plus 5 pi is 7 pi over 3. Divide by 2 gives me 7 pi over 6. So the divide by 2 goes in the denominator. So there it is. I have now marked off my 4 quadrants, and I actually have the coordinates of those 4 quadrants. Those are my quadrant boundaries. So my vertical shift. I now put in my vertical shift. When I put in my vertical shift of plus 2, I have to make sure I can account for the fact that I still have to be able to fit my amplitude of plus 3 in, or 3. So there is my vertical shift at 2. So I draw in my middle line. So this represents the middle line of my graph. So there it is. So now I have my quadrants, I have my middle line. I can use my amplitude then to draw in my points. So it's a sine graph. There's my starting point. It's going to start in the middle. I need to make sure I can go up to positive 5. So the middle to the plus 3 is going to be positive 5. The middle down 3 is going to take me down to negative 1. So it's going to go from the middle to the top, back to the middle. Again, these are my 5 reference points. Down to negative 1, back to the middle. So those are my 5 reference points. It allows me to draw my quadrant symmetry. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I've drawn in one full period of this sine graph.